Hey, everybody, and welcome to another episode of Adventures in Machine Learning. This week on our panel, we have Gant Laborde.
Hey!
We've got a couple of new panelists. We've got Jason Mays.
Hello there, nice to meet you.
And Daniel Svoboda. I'm going to stumble over your name like every time, dude.
You can get away pronouncing the V like a W or a U, so Svoboda.
Svoboda, okay. Yeah, I lived in Italy for 2 years, and SV is totally fine in Italian words, and it's zv. So yeah, anyway. So yeah, I'll have to remember that. I'm Charles Max Wood from devchat.tv. I'm just going to remind everybody real quick to go check out mostvaluable.dev, which is kind of my current passion project. And our guest today is Laurence Moroney. Are you a software engineer trying to learn machine learning? Then you should check out the course from educative.io called Machine Learning for Software Engineers. It has 87 lessons, 8 quizzes, 115 challenges, 163 playgrounds, and 2 code snippets. In other words, it's not just a set of videos that tell you how to do the thing. It actually walks you through all of the processes for machine learning. It gives you quizzes, it makes you do challenges, it's very hands-on. It's done with experts from companies like Google, Microsoft, Amazon, and Apple. And it is a terrific course that I've been learning to do machine learning. So go check it out at devchat.tv/learnml. That's devchat.tv/learnml. And that'll take you to the right place so you can sign up for the course. Laurence, do you want to introduce yourself and tell us why you're important and super cool?
Well, I can introduce myself. I don't know if I'm important or super cool, but maybe we'll decide. So I'm Laurence Moroney. I lead the AI advocacy at Google. It's my privilege to work with folks like Jason. And it's my job to try and bring AI and machine learning to developers and to really help developers understand what they can do with it. It feels like, for many years, AI machine learning, you needed a PhD to be able to get anywhere, but that's not the case now. And it's my job to inspire and inform people who are coders rather than people who are academics.
Yeah, I love that. Mostly because I love coders.
Me too. Not that there's anything wrong with
say,
academics. I love them, but it's my job to inspire the coders because I'm one of them.
Yeah. I also have to point out that Jason is definitely a privilege. Anything with Jason. So.
Yeah.
Very kind of you.
I love meetings with Jason because I can just sit back and he just goes. It's great.
Wow. Yeah, you just wind him up and you didn't have to work for 2 hours. I love it.
Pretty much.
So, yeah, we've kind of talked in general about machine learning and kind of getting the hang of it and things like that. One thing that I'm curious about, just to get the conversation rolling, is how is the focus on developers different from maybe the rest of the industry's focus or parts of the industry's focus? Do they focus on different people?
So I think a lot of the focus on developers is a focus on the kind of things that you can do with machine learning, as opposed to here's a cutting edge algorithm, here's a cutting edge technique. If you tweak this hyperparameter, you'll improve your performance, and the type of things that really appeal to those who are pushing the envelope. The way I always like to think about it is that when you're dealing with developers, their audiences are millions, if not billions of people. Right, your developers are the folks who write apps that are used by everyday folks. When you're dealing with research, in many ways, the audience is an audience of one, that a person who is a researcher has to stand up and say, I've pushed the envelope in this way, either through a thesis or through a paper or something like that, and then prove that they've actually done something. So how you build machine learning, how you build education, how you build materials varies greatly depending on the audience.
I gotcha. So some of the industry's focused on here's how you make some process better, right? You're going to save money or whatever. And some of the focus is on we're innovating in some new way. So yeah, it's research. And so you're kind of out there gaining prestige among other academic people. And then you've got the people who are actually out there with the hammers and nails and neural networks and, and they build solutions for people so that life is better.
And eventually that thing that the researcher does, where they push the envelope, where they do something better, will get pulled through into a product, or might get pulled through into a product. But it's just a different part of the pipeline. And what we've kind of identified, like pretty much only in the last maybe 18 months to 2 years, is that now there are sufficient things in that pipeline for the average software developer to be able to pick them up and do something revolutionary and different with it. without needing that kind of deep academic background, without needing a PhD, as I always like to say. It's, you can succeed at this kind of thing. And then with frameworks like TensorFlow, not just being the framework for building machine learning, but having all of that stuff that's orbiting it, where you can deploy it. JSON's a maven at TensorFlow JS, for example, where there's a JavaScript version of the library where you can not just do inference in the browser, you can train in the browser. There's a thing called TensorFlow Lite where mobile developers are now welcome to the party, that kind of thing. And there's TFX where enterprise developers, people who are building like these big pipelines for massive models and for constantly maintaining and updating models, they're also part of the party. So it goes beyond just pushing the envelope of machine learning, but into different ways that you can now start using it.
I gotcha.
Yeah. What's really funny is that I've watched this transition. You said it's happened over probably the past 2 years. And what's great is, by the way, Laurence, I'm a huge fan of yours.
Oh, thank you.
So I started off with Andrew Ng. So there's deep learning AI. And then, I think it was like 2012 or something like that, Andrew Ng did his original, let's get you started in machine learning. And I didn't know that I had to remember everything about mathematics when I started that. But it was quite difficult. And then what's great is you showed up on sort of that channel as well and started actually kind of taking it way more towards developers. And I think that's where the rubber hit the road for me, is that there's just a lot of really amazing stuff and sort of like, yeah, I've seen it over the past couple of years as like developers are saying, hey, this is a product I see. I wonder if I can do that. Now there is actually information out there for people like that. So
yeah, exactly.
It's fantastic work on that. What does that adventure look like? Were you in a conversation with Andrew and then said like, look, let's take this to the next level? Or
yeah, kind of. So it started for me, I would say, probably back around the middle of 2018, so a little over 2 years ago. And at Google, we had this. I was working on Firebase at the time, if you know Firebase.
Yes.
Very cool product.
I love Firebase. David East is so cool.
Isn't he?
Yeah.
East, as we call
I
him.
have an Angular show, and we've had him on several times. So
yeah. So David and I were colleagues. We were both working on Firebase, like doing the advocacy for it. And, at Google, then we said, during 2018 is that every software engineer, every engineer should be trained in machine learning. And I was really excited because I'd had a background in AI, which goes all the way back to 1992. And it's a long story, which I can tell a little later if you like. And I was like, oh, good. There's all this new stuff going on in machine learning. This is exciting. It's revolutionary. I'd done Andrew's course a little bit. I was studying a machine learning course in Stanford at the time, but it was like, now we have the internal stuff. We're going to see how the secret sauce is made. And I remember, I'm based in the Seattle area. Got a big office in Kirkland, which is one of the suburbs of Seattle. And the biggest conference room in Kirkland was packed full of software engineers. And we started learning about machine learning. And I was sitting there with a friend of mine, and the two of us, we were the same. She was excited, I was excited. And then we started learning about machine learning. And I remember the first hour and a half, we were doing calculus. And you could feel the kind of enthusiasm slowly deflate out of the room. And I was like, I haven't done calculus in 30 years. And I was kind of looking at this and okay, get through this. Then we get on to machine learning. But it just was more and more and more calculus. And by the time we were an hour and a half into this and it was supposed to be an all day thing, I look around and people are doing email and people are browsing the web and she's on her phone and I'm like, oh, forget this. I'm going to do. And I was really disappointed in that, that's what learning machine learning looked like. So then, I brought that to the TensorFlow team and I was like, hey, we really should be teaching this to developers. And they're like, okay, you do it. So that's how I.
That's how companies big and small. We really should be. Yeah, you go do that.
Yeah, so pretty much. And I was like, oh, so I get to work in AI now. And they're like, yeah, okay. And so I transferred out of the Firebase team, and I've been working on something called Firebase Predictions, which used TensorFlow in the back end, and that kind of stuff. So I had a little bit of familiarity, but I was really excited about bringing stuff to developers. So I was able to move teams and join the TensorFlow team and do that. And that was when we were ramping up TensorFlow 2. And TensorFlow 2 had an interesting pivot where Keras was becoming a first-class citizen of TensorFlow and eager execution was being enabled by default. And now suddenly the framework was there to make it easy for developers. And, you could do step-by-step debugging, for example, which you formerly couldn't do when you loaded everything into a graph and executed on the graph. And so one of the first things I proposed was, we had worked with MOOC companies before. Let's start putting together a really good MOOC for developers. And let's speak with like a lot of the MOOC providers. And so we put out some feelers to some of them. And deeplearning.ai were one of the ones that came back to me. And my screensaver just kicked in. So let me just type my password so that I can see you. And hopefully you can hear me. There we go. Yeah. And they were kind of interested in this, but they wanted to know the angle that we were taking. So I was fortunate enough to meet with Andrew. And in my first conversation with Andrew, I gave him the pitch that I give to everybody. And that was, there was research done a few years ago by a company in China to count how many AI practitioners there are in the world. And they came up with the number 300,000. And I was like, okay, let's start with that number as a basis and say, how many software developers are there in the world? And there's various research all over the place saying everything from like 20, 25 million to 30, 35 million. And at the recent WWDC, I think Tim Cook said that there were 25 million Apple developers alone. So I kind of looked at like a bunch of these numbers and I just rounded them up to 30 million. And so then, like I said with Andrew, hey, there are 300,000 AI practitioners in the world, but there are 30 million software developers in the world. And if we can train just 10% of those, that will give us 3 million, and we increase the number of AI practitioners 10x. But in order to reach those folks, it has to be a code-first approach. It has to be a solution-first approach. And I would really like to teach it in that way. And that's pretty much how it all started. So, and that's like how I still like to portray it. And if I go back to the 300,000 number, that was, how do you measure the number of AI practitioners in the world? And when I looked at their methodology, it turned out that they were measuring AI practitioners by the number of people who've had their name on an academic paper. And that's where they got the 300,000. And that was the only way it could be measured, to be fair. And so we're like, okay, if we kind of make it something that's part of a software developer's toolbox, then that's the kind of thing that, if we get, like I said, 10% of the 30 million software developers, now we're really changing not only how many AI practitioners, but what an AI practitioner actually is by definition.
Yeah, I think it's basically an expanding art because I went for my master's in 2012 in machine learning. And when I graduated, I was trying to look for all jobs, and literally all jobs were requiring PhDs at that time. So yeah. I was wondering if I was going to resign myself to just being a programmer or going back for a PhD. But then I started noticing in 2014, the requirements lowered to a master's, and then 2015, 2016 to a bachelor's. And now they're even advocating code camps, for data scientists, which I don't know how you're going to do a crash course of 12 weeks in calculus, but if they can do it, they can do it.
That's such an interesting. So Daniel, you've gotten a perspective of being in this field for a while, and Laurence, you said that you've been doing AI since the 90s.
Since the 90s.
For some of us, we've feared AI since the 90s. What I'll say is
too many movies.
Yeah, that's what it was. All the really good movies have evil AI. All right, you can't have. Yeah. There's too many movies where the good AI is just a bad movie. But from my perspective, though, it's kind of interesting to see how kind of going back in time, sort of like what you're saying, Daniel, is that I've only seen a recent history, and I think it's because ImageNet, surpassing human-like capabilities, the advent of getting into GPUs and CUDA, and it's just sort of the ability now that it started and all the way to today, where Jason's putting it in a browser and people are making websites with this. It's so tangible today.
Yeah.
It going backwards in time, you start getting into that AI winter, and sort of seeing it. What I guess I'll start off with Laurence and then sort of be what made you actually still go into this when I think 90s was still AI winter, and then kind of you could toss that over to Daniel at some point and maybe figure out how were people still working on this when there was just no information on it and there wasn't courses and there wasn't stuff for developers.
Yeah, so I'll talk about the 90s version of it, or late 80s, early 90s version of it. Was it's kind of a funny story in that I graduated university in 1991 and I was living in the UK, and my major was actually physics. And if you know anything about UK history in the early, total nerd, and I love quantum and all that kind of stuff. I want to get into quantum computing next. And I was like, you were completely unemployable. It was in the middle of a massive recession. Actually, at the time, I was working as the front guy in one of those shops where you bring all those empty cans that you pick up on the street to recycle. I'm not kidding. And that was the only job I could get. And I was working at that job and I was trying to figure out what am I going to do? Am I going to try to go back to school? Every day I come home stinking of, like stale beer and stale Coca-Cola and all of that kind of thing. And the British government at that time were trying all of these different initiatives to try and get people who are qualified out of unemployment or out of crappy dead-end jobs. And one of the things that they launched was a vocational qualification as opposed to an academic qualification in AI, because they identified that AI was possibly one of the biggest trends for the future in the UK. And to be maybe able to pick up British business and all that kind of thing. So they sent out this call for people with a bachelor's degree who are currently unemployed or in a dead-end job to apply and become part of the first cohort. And I actually got in. And nice. So I was actually the first person accepted to it, which was quite the privilege. It was really nice. So the second city in England is called Birmingham, not Birmingham, Alabama. There's a Birmingham in the Midlands. And so I remember going there in the middle of 1992, and they launched this course. There were 20 people accepted into it. It was a complete and miserable failure. I think it lasted about 3 months before, the people in the course, the cohorts who had given up their dead-end jobs to come and learn this were kind of attacking the teachers with pitchforks. And because all that you could learn in AI at the time was, there were really two programming languages. One was called Prolog. I don't know if you've ever heard of it. And the other one was called Lisp. And Lisp is a really interesting language for list processing, which gives it its name. But syntactically, it's a very bizarre language because everything is bracketed. You'll wear out the brackets on your keyboard just typing a Lisp program. And there was no real end game in sight. There was no real employability from this. It's like, okay, we'll study this for like 2 years and we'll know how to program in Lisp and Prolog, but nobody's hiring in that. And it ended up being a complete failure, but because they felt sorry for us and because some of us who had kind of signed up for this thing had given up our jobs, they ended up, you're able to do a master's degree in that city that they would fund it. So I was able to transfer that to become a master's degree in electronics of all things. And, that's what kind of kickstarted my career. So I think that was kind of, you mentioned the AI winter, and that was kind of part of the AI winter because they made a gutsy decision to try and see if there could be something done in industry. But when the stuff in AI at the time was very much bleeding edge research, academia, and you didn't have that pipeline to draw it into industry. And their gutsy attempt at that was to teach people Prolog and Lisp. I really admire them for doing it. But to me, it was like, that's a classic example of why something like an AI winter could happen. And why it's different this time is like really what I was mentioning earlier on, where there's all of this stuff happening in cutting edge research. But, much of that is making it over the fence into product and then making it over the fence from product into APIs that, outside developers can use. It's not just ring fenced by the companies who are making the AI technology. And that to me is the big, big, big difference this time. It actually has come full circle because the UK government is now, they have like this cross-party parliamentary committee that works in the House of, the UK government has two houses, House of Commons and House of Lords. Right. And they have these cross-party committees now researching like how AI can be used for the future of the benefit of the UK economy. And they brought me in as an advisor. So it's like, wow, it's kind of completely come full circle that, I told them that story and they've been madly looking up the records. Like, who is responsible for that program? I want to buy one of those like kind of gray wigs, but.
Oh, nice.
That's a good idea.
No, I know
that
this is now seen as like the fourth industrial revolution. Like all these technologies with AI, they're seen as like industrial revolution unto itself. I mean, we don't know what might be the end cause after the end result of this revolution. Is there going to be like mass unemployment? Is there going to be like, are we going to be serving our like new robot masters? Basically, like everything is completely in flux now at this moment. It's kind of thrilling and exciting at the same time.
Yeah.
Yeah,
Well,
well, and
Lawrence was gathering metal for them since the late 80s. So they're going to take kindly to him.
Absolutely.
And then they kicked him out and put him in from his dead end job to his dead end course. I mean, it's interesting though, because a lot of this too, like the other industrial revolutions, you could see the transformations physically manifest, right? And a lot of the AI stuff, my wife and I just watched The Social Dilemma on Netflix, and it talks about how they have the AI systems that are essentially set up to model you, right? And to get you to do certain behaviors. And so the thing that I think is interesting about this, I mean, some people go, yeah, robotic overlords, something like The Matrix or, some of these other, apocalyptic movies, or, well, it's the AI is going to learn to do these jobs. And yeah, robotics will essentially take over like assembly lines and stuff. But what's really interesting to me is how much behavior is it going to be able to push us to, right? That we're not even going to see. Like the way that the other industrial revolutions changed my life was I got air conditioning, right? Which is real nice. Or, cars got cheaper or something like that. But at this point, the AI can play with personal behavior. And some of the things that I probably get pushed to do with some of this stuff, I don't even realize. And so it's really going to be fascinating to see the provable outcomes from AI. That's not to say it's not going to make our lives better, because I deeply believe that it will, and it'll give us better ways of solving certain problems that have been intransigent. Never mind, I'm not going to say it. You know the word. Up till now, these unsolvable issues. But yeah, I think more than any of the other changes that we've seen in our economies and our technology spaces, this one's going to be kind of a double-edged thing, and we've got to be paying attention to it.
The rate of change is going to increase as well, and like each leap we do will be shorter and shorter, but more will be done in that shorter time. So there was a great blog post on this I saw a little while back. I've forgotten the name of the author now, but there was this blog post around if you were to go back in history, the number of years it would take in order for someone to die from shock from the rate of change, essentially. And back in the old days, it might be like a century or something like this. If you brought someone from a century ago into this world, they'd be like, oh my gosh, what is all this stuff? And now they're saying it's going more towards like 10 years. And like if you brought someone 10 years ago to go see this stuff, it's going to be just nothing like you've ever seen before. So I think that's very interesting too, to see how fast it's actually progressing in that way too.
Right. And, one of the things that ties in with that is that makes education even more important. And it's really strange because, AI is doing things that people have never seen before. And there's that classic quote, indistinguishable from magic, vast enough. And the problem is who holds that magic, right? And I think that if it's a few people who actually hold that magic, then we actually have some significant problems. Like we see people doing crazy things with deep fakes and generating entire articles and stuff like that. So that's why actually I really applaud the people who are going towards education, because the more that we know these things exist, the more we actually identify and kind of like work with those things. In my opinion, it's more and more important that we have this, like you were saying, this changing world. You need people who are nice and help you along the way with those changes.
I think the more
to that
people
point, I want to ask you, Laurence, because you're working in this space and you said code first, right? So we're talking functionality, but yeah, at what point do you start introducing ethics, and things like that, where we've all kind of been talking around some of these issues that could come up from this, right?
Yeah, so we try to introduce ethics as much as possible at step zero, just to introduce it as soon as you can. It's kind of hard to do that, at least at the beginning, for people who are only just getting started with this kind of stuff, because it's hard to tell somebody that you have to be ethical using this tool before you teach them how to use the tool, right? You can't teach somebody how not to use a hammer before you teach them how to use a hammer, and using a hammer, they'll occasionally hit their thumb and hurt themselves. I've been there. And, from that, you realize that you could also hurt other people, and it becomes folded into being a part of the process. So like ethical use of this is as important as possible. But just go back to something that we've kind of mentioned a few times already. And it's one very interesting difference in this revolution in AI than we've had in other previous revolutions, is that we have a history of fiction around AI where AI skews negative. And as a result, in many ways, we've introduced a negative bias towards AI in society through that fiction. I always like to say probably the first sci-fi novel ever created was Mary Shelley's Frankenstein. And when you think about it, that's an AI, right? It's like a reanimated body with an artificial intelligence introduced into it, and it goes rogue and goes crazy. Even like there's some like religious literature and other stuff that goes earlier where there's sometimes you can apply AI to things that people say are the bad guy in that. So throughout history, it's almost been a foundation of like science fiction that AI equals bad. And those of us who tend to be working in this field tend to be science fiction fans. So we've been exposed to it more than anybody. So there's an inherent bias there that I think sometimes we might want to crack through that bias to see the reality. And that's part of what I like to do when I teach it to folks is that, Arthur C. Clarke was the one with the quote that any technology sufficiently advanced is indistinguishable from magic. And it's like, okay, I want to show you that this stuff really isn't that advanced. When you look at like deep learning and you look at, for example, a neural network, the average person, the lay person will see that as, oh, it's a computer emulation of the human brain. And I'll teach, no, it isn't. It's a bunch of little functions that are learning two parameters, like, y equals mx plus c. And can you imagine like millions of y equals mx plus c's all working together, and look at some of the great stuff that it can figure out. But it's not like I'm sitting at my keyboard now programming a human brain, so stuff like that. So when it comes to the revolution and the impact of the revolution and the potential negative impacts of the revolution, I think we've kind of skewed a little bit too negative. And I'm not just saying that just in case our future robot overlords are watching this on YouTube. I think we've kind of skewed a little negative in that way. And one of the good things is if we can cut through to the reality of this. And Gartner have the hype cycle. Do you know that curve where you have the peak of inflated expectations and then you fall into the trough of disillusionment? And from the trough of disillusionment, you start climbing towards productivity. But it begins with that really sharp peak. And whenever we seem to talk about AI, we're talking on the left-hand side of that peak. And I like to try to, quantum tunnel people through that into the trough of disillusionment so that, they can know where they are at any moment in time. I always like to say I'm a professional disillusioner and anti-magician, as it were. And then like once you're in that and you realize what's actually possible with this, then you can climb up into productivity and start doing things that are real and cool and amazing. And then one other point on that would be talking about revolutions that I like to try to learn, and my screensaver kicked in again. I guess it doesn't want me to talk about this part.
We can still hear you. Just keep going.
So talking about, I like to learn from the more recent revolutions. And in my career, this to me is the third huge technological revolution. The first one was the advent of the web. And then the second one was the advent of mobile phones and smartphones, that kind of thing. And I'll talk about the web advent first, where in many ways that was a more disruptive one. For example, if you take a look at retail and the high streets and those kind of things, how the web has disruptively impacted that. Because I remember like when I was living in the UK, when I was studying in the UK, my family lived in Ireland. So I'd have to travel back to Ireland from time to time. And that meant I would have to get on a bus, go down to the high street, find a travel agent, talk to a travel agent, have the travel agent find me a flight, and then I buy the flight and then he or she prints out a ticket and hands me the ticket. And, you just don't do that anymore, right? That was one of the things that was massively disrupted by the web. But have things gotten better? As a result, the air industry has grown dramatically. The travel industry has grown dramatically. But the jobs of the people who work in that store have gone away. So it feels like there's a massive net gain economically, and there's a massive net gain when it comes to jobs. And I would argue that a similar kind of thing happens in every technological revolution. And I think the AI one will be the biggest revolution and have the biggest impact in that way. Of course, there's always disruption. Some industries will go away, but there'll be a net gain in what replaces it.
That was amazing. All the answers specific. Plus, you threw in quantum tunneling. So I'm very happy about that.
I told you I was a physics major.
Hang on, let me find my X-Files theme to play. Leveling up is important. I spend at least an hour every day learning ways I can improve my business or take a break and listen to a good book. If you're looking to level up, I recommend you start out with the 12-week year as a system to plan out where you want to end up and how to get the results you want. You can get it free by going to audibletrial.com/code. That's audibletrial.com/code. I think it's interesting, though, because, you talk about sort of the machine learning literature movies. And it's easy to set up conflict. And essentially all conflict boils down to this. But conflict is essentially another intelligence that we don't understand that has goals that we don't get, right? And so it's easy to set it up with something like a machine or AI, right? But yeah, the capabilities and the possibilities are exciting. So I kind of want to jump into the nuts and bolts of teaching developers machine learning. So where do you have people start, right? Do you give them a problem to solve? Do you just kind of get them familiar with the technology? Do you start somewhere completely different?
So, I mean, everybody starts programming with Hello World. So I kind of I give what I believe to be the Hello World of machine learning. And that would be, what's the simplest possible neural network? It's a neural network that has one layer, and that layer has one neuron in it. And if you can learn what one neuron does, then you can begin to cut through the illusion of what a neural network is. So like all that false illusion that I was talking about earlier on. So then I give them like the programming problem where I give them a set of X numbers, and I'm going to go into math now. I'm going to give them a set of X numbers and a set of Y numbers, and there's a relationship between the X and the Y. And I ask, can you spot what that relationship is? And usually it's where Y equals 2X minus 1. And so people will kind of look at it and they'll go, oh, I see the Y is increasing by 2 every time the X increases by 1. So it's Y equals 2X plus or minus something. And then when X equals 0, Y is minus 1. So I'm going to make a guess that it's Y equals 2X minus 1. And then I'll make that guess, and then I'll fill in for all the numbers to see if it fits. And it fits, and then they'll give the answer Y equals 2X minus 1. And then I go, congratulations, you've just done a machine learning algorithm in your brain, because that's exactly how it works. And then show the code for, here's a neural network with a single neuron, here's the numbers, and then here's like, the one line of code that where the mathy stuff is abstracted away. It's like in TensorFlow, you compile your neural network and you give it a loss function and an optimizer. And I'll then teach that, okay, what a neural network does is it has no clue, it's not as smart as you are, and it's just going to make a guess. There's two parameters here. It'll make a guess, say, Y equals 10x plus 10. And then what it'll do is, okay, it'll look at the numbers that it has. It will take a look at its answers. It'll take a look at the real answers. It will realize that its guess is really crap. The loss function is the thing that measures that. And then the optimizer is the thing that takes the data from that guess, takes the data from what knows already, and generates another guess. And you repeat that loop again and again and again while the guesses get steadily better and better and better. And all of the calculus stuff is hidden inside that optimizer function. You don't need to learn that now. You just need to learn the code and go through that loop to see how it works. And then after running that, it pseudo-magically comes up with something that's very close to the correct answer. So that kind of is my way of at least getting people started with machine learning. It's simple. You can write it in 5 minutes. You can see it working. And it also begins to cut through many of the illusions around machine learning and tunnel them into that trough of disillusionment right away so they can start seeing what's possible.
Yeah. What's the most interesting aspect of people seeing this for the first time? Developers and a lot of people listening to this podcast are used to this binary truth of accuracy being everything. Either the code runs or it doesn't run. And then you've introduced this aspect of how wrong are you in figuring out this. And I think that's like one of the biggest leaps is that, it's always going to be like, I'm 99% sure. You're like, are you, what?
Yeah.
My code's not very sure.
Yeah.
or it's getting more and more sure. I think that's like one of the cool concepts that Hello World kind of gives you. It's because I can't tell you how many times, a developer comes along and they have to sort of they have to reevaluate everything that they've ever thought of programming. It compiles or it doesn't compile. What's happened? Or in JavaScript, hey, it runs and it's wrong, or it runs and it's not wrong. I have to jab JavaScript here and there. I love it. And I love that it's there. But I think that's such a great fundamental aspect to start at. And do you ever actually do any teaching in person where you, when you came up with this concept, did you get to look at people and do this? Or
yeah.
Oh, that's so good. So do you have a big teaching background as well with all this?
No, not really. But as part of the job of a developer advocate in Google is you generally go to meetups and you go to Google developer groups and stuff like that. And so, I was invited to quite a few of them when it was I was the TensorFlow DA that people saw on YouTube. And so before I started writing the course this way, it was okay, I wanted to test that message in front of an audience. And it really works in front of an audience. And that's when I thought, okay, this has legs.
That's fantastic. Actually, I kind of want to bring the question around a little bit as well to some of the other panelists, because I think our audience would really like that. What are, and honestly, Laurence, if you want to you want to jump in on that in any sense. What are some of the things that when you're first talking to somebody about machine learning that, who's been a developer, what are the tripping points? What kind of gets them sort of saying, wait a second, what?
I mean, for me, I think like most of them are used to logic. And, machine learning is all these variety of subjects. It's calculus, it's optimization. But I would say that there is sort of mostly a probabilistic statistical component to it. And I think sometimes people are not able to wrap their heads around like concepts of statistics. I mean, you'll do something like, let's say, oh, we are predicting this with 70% accuracy. And then everyone automatically assumes, okay, so that's what's going to happen. And 70% doesn't actually mean that. It could mean like there's a high likelihood, but not a total probabilistic likelihood of that happening. So I think in one ways, people have to adjust their mindset from like a logic-based to a statistic-based. And some people are not really able to like completely do that, not without like forcing themselves.
I have to agree. I can't tell you how many times my partner, Alicia, she's like, it's going to rain today. And I was like, oh, is it? She's like, yeah, it's 20% chance of rain. And I was like, I don't think that means what you think it means.
Building on that, actually, like I see a lot of people get stuck on what threshold to cut things off at. So like, 20% chance of rain, that might be like in regular human terms, that it's a decent chance, 1 in 5. But in machine learning terms, that could be meaningless, right? So knowing when to cut off, and like sometimes you 0.99, so 99% chance of something being correct, actually accept it as the answer rather than 80 or 70, and knowing what that threshold should be. Often I see a lot of people get like, oh wow, it needs to be higher than like 80. So yeah, I think that stumbles people sometimes.
And it's a 30% chance of rain on the test set, but only a 20% chance of rain on the validation set.
Well, Laurence, I don't know if you've known this, but I have a solution for that. If you just train on the test set, you get way better. Way better.
You should patent that.
My models all get 99% accuracy. I don't know if people have written a paper about this, but that's a good trick. Right now, developers are like, what? And machine learning listeners just all tuned out immediately.
We just had a machine learning dad joke.
Yes. That's exactly. I have plenty of those. Well, that's fantastic. And, you've kind of given back in a few things. Laurence, one of the things that I first saw you for, by the way, and is you actually were creating data sets from 3D models. And I think you had like the hand model, human or horse, and some stuff like that.
Horses are humans, yeah.
Yeah. So what kind of got you into doing that? And is that more that we're going to see from you? Or was that like a stage where you were like, you needed some data, so you just went ahead and made it? Or?
So yeah, it's I do like the 3D sculpting, digital sculpting kind of thing as a hobby. And I was having trouble finding some data sets that I could use for like teaching, for distributing via like Coursera and that kind of stuff. And we really wanted something that was unique, and not to do the same thing that everybody else has done, like cats versus dogs and MNIST and those type of things. So I was like, where on earth am I going to find these? And I was like, wow, if I were to try and hire a photographer to go out and take pictures of lots of different people and horses, for example, I originally started it as horses versus dragons, by the way, rather than horses and humans. I was rendering a whole bunch of dragons and I wasn't rendering. I was like kind of thinking this idea because Game of Thrones was huge at the time.
Yes, that's totally what my brain was saying. Yeah.
Yeah, and so it was like, maybe that would be a good idea, but it was like, no, it would take too long. And then I was like, okay, well, what if I did like horses and humans? But I took a look at what it would cost to get a photographer to go out and take lots of different pictures of horses and lots of different pictures of humans. It just wasn't feasible, and like particularly with the humans, because you got to deal with all the releases and all that kind of stuff. And then I was like, hey, what if I kind of just render these myself and I'll give it a try? And so I ended up like, just rendering myself. And the interesting thing was I didn't think renders would work because they're CGI. And then I thought, okay, well, if I train a neural network on CGI, then I could only really classify CGI images. So I created another test set of horses and humans that we could say for learning it. But then when I try it on actually classifying real pictures of people or of real pictures of horses, it actually kind of works because, when you're training with a convolutional neural network, it's spotting features. And it just happens to be that if you have a close to photorealistic image of a horse or a human, the features that it spots are very similar to the ones that would be in a real image of a horse or a human. I was like, boom, then at that point, then synthetic data sets then become possible. And so the other part of the question, am I working on any others? The answer is yes, I am. So one of these days I'll get it out. I started working on some that were a motion. So I had like a bunch of faces where they're happy and they're sad and they're angry and, those kind of things to see if I could kind of use synthetic data to build an emotion detector. But I haven't gotten around to finishing it yet.
All right. Well, yeah, I'm looking forward to it. That's awesome. There's some good stuff there. It's always good to have extra data out there. I'm surprised by the amount of data that people will just sort of give away. And getting into the industry and just kind of take a look at it, it's like, do you want to know if there's a volcano on Mars? I was like, that's a data set? Like, who did all that? So that's fantastic. Thank you. Now I care about that stuff.
Totally.
Awesome. Do any of the other panelists have any other questions for Laurence before we move on to the picks?
I've got a quick question around synthetic data sets, actually. So it's an interesting topic. And obviously, we've got very visual examples there, but I'm wondering, Laurence, if you've seen any examples for non-visual synthetic data sets.
That's a great question, and not yet, but that's actually one of the things I'm kind of sort of working on, that one of these days I'll have time to work on anyway. But I've seen, if we go back to, there was a question earlier on, for example, about bias. And often you can look at some data sets, like say non-picture data sets like CSVs or text-based data sets or something like that. And you could use statistical analysis techniques to enhance those data sets in areas where they currently don't have data. Let me just throw out, this isn't one that I'm working on, but I'll just throw this out as an example. Like say you were trying to look at data of employees in tech. There's a significant minority of employees in tech are female. All right. And so if you were to try and train a machine learning model for something on that kind of data, you're already introducing an anti-female bias.
Yep.
But you could use statistical analysis techniques on the set of female data that you have to enhance that data set, to create new records that are in line statistically with what's there already, but are separate and distinct from what's there already. In much the same way as, for example, if you're training a convolutional neural network with images, often a way to prevent overfitting in sets is to use image augmentation, where you rotate the image and you zoom it and you kind of sort of create new images that are, I don't want to use the word fake, but they're different versions of the existing images to help you spot features that you normally wouldn't have seen. And I say, well, why can't you apply the same thinking to like numeric data or text-based data to artificially remove, it is artificial, but it's a way of removing at least some of the bias that might be inherent in those data sets. So, and all you got to do is open up Excel, look at the data, start writing some macros to kind of take that data and say, well, say the average age is in this range, the average age of people at this location is in this range. So I can start creating new records that that aren't outliers statistically, or at least aren't too much of an outlier statistically, and then have a synthetic data set to enhance an existing data set to potentially remove some of the bias.
That's a great way of kind of like coming along. I find a lot of people say, throw more data at the problem, right? And what you're saying is like, don't work harder, work smarter. If there's something that more data would fix, or even if it actually, in some cases, it probably wouldn't. But you can actually work specifically to balance the data set so that it's appropriate for what you're trying to actually predict and infer. Nice.
Or even worse, that there are people who will walk away from it if the data isn't there. And I don't want these people to walk away. And I'll be like, hey, there are things that you can do. 80% of a solution is better than 0% of a solution. And I know that this isn't going to be perfect using synthetic data in much the same way as using, CGI, horses and humans isn't as good as using photographs. But at least it's getting you heading in the right direction. And at least it's getting you thinking about the problem.
Yeah. And I'm glad you moved to synthetic data for the horses. Actually, if you're getting a professional photographer, take pictures of horses and dragons, that photo of that dragon is expensive.
Totally. I mean, Jason's working on the time machine for me that I think he needs to go back to China. How's it going, Jason?
Yeah, it's getting there. There's a few technical issues, but
that reminds me. There's this protest chant. What do we want? Time machines. When do we want it? It doesn't matter.
Yeah.
So we're getting very nerdy now, I'm sure.
The nerdier the better.
It's perfect. Actually, listeners at home don't see, but I have like a nerd triggering shirt. It's
nice.
It's if you're a Star Trek or just a Star Wars fan, you'll be angry. But I've combined the two on my shirt.
Oh, it's Star Wars. I thought the thing on the side was an AirPod. But I see now it's the cockpit of the Millennium Falcon.
Yes, indeed. Yeah.
I'm trying to figure out how you had AirPods on the Enterprise, but
indeed.
Just train an NLP algorithm on Star Wars and Star Trek ontology and see what comes out from it.
You know what? I think that's... I could use way more of that stuff. For tutorials, I've found that the visual stuff's been fantastic. There's some really good ones on NLP, but everything that I've put into NLP, maybe because it's one of my weaker points. And Daniel, maybe I should sync up with you offline a bit, because I know you work on a lot more of that. I'm starting to see that's kind of like what's coming in. Like GPT-3 is really bringing, like, every tweet talks about like how to generate cool text. And the last time I tried to generate cool text, it did not come out good. We need someone to make a code lab on how to make it not bad. So.
I have only one word for why it's so awesome, and that's Transformers. Just Google it online, and you'll completely
the movie. Okay. The first movie was good. I didn't watch the others, so I'll...
Every time somebody says Transformers, I just think robots in disguise.
Yeah, that's right. That's perfect. All right, Optimus Prime. I think it's prime time for us to go straight into the picks.
Hey, folks, this is Charles Max Wood, and I just launched my book, The Max Coder's Guide to Finding Your Dream Developer Job. It's up on Amazon. We self-published it. I would love your support. If you want to go check it out, you can find it there. The Max Coder's Guide to Finding Your Dream Developer Job. Have a good one. Max out.
The picks is a portion of the podcast at the end where we all just mention one thing or two things, if you really want to, that are cool, that you would like to call attention to. This is your free chance for marketing. Obviously, this episode will go out in about a week or two. So if it's anything that's too soon, it'll be too late for that pick. And so I guess we'll just kind of kick this off. I'll start it off in case you don't have your picks ready. And you can think of something, of course, you can pass as well. But one thing that's pretty cool that I'd like to go ahead and do for my pick is specifically, I'll say, I did this cool project called TensorFlow Tic-Tac-Toe.co, where you actually teach a tic-tac-toe how to, like, the AI is terrible. It's just guessing, like Laurence was saying earlier. And then as you play games with it, it slowly learns how to actually play tic-tac-toe and become, as I will say, unbeatable, but I'm no champion at tic-tac-toe, so maybe it could be better. So if you want to check that one out, that is at TensorFlow Tic-Tac-Toe.co. It's that way because it sounds so fun. Yeah, I didn't cut. Yeah, I could have gone .com. That was not TensorFlow Tic-Tac-Toe.com was not taken. It's the rhyme that was important there. All right, and then I'll throw it over to you, Jason. What do you have any picks?
Yeah, so I'm going to have to give a shout out to the TensorFlow JS Show and Tell on YouTube. That's coming out very soon. But by the time you're listening to this, it will be available for rewatching, of course. So check out the TensorFlow YouTube channel and check out the TensorFlow JS Show and Tell for 8 great presentations from members of the community on awesome projects they've made, such as Tic-Tac-Toe and much, much more. So do check that out.
Nice. Very nice. Awesome. Definitely. And then follow Jason if you can on Twitter. He's always got these cool events kind of happening. So Jason Mays, and you'll see his stuff in the show notes. But these show and tells, I believe it's the 3rd one. So
yeah, and finally on our new home on the TensorFlow channel. So hopefully we'll be able to reach more folk as well. So
beautiful.
People, use the hashtag made with TFES, and you might get a future show and tell. So we'd love to see what you're creating. Yeah.
Perfect. Yeah, so reach out to Jason, especially if you create something. That'd be perfect.
Exactly.
Awesome. All right, Daniel, do you have any picks?
Yeah, I would like to give a shout out to Kaggle, both like the online community, and now they have like their own YouTube channel. And
Oh,
the great thing about the YouTube channel, and this is what like Laurence was talking about between developers and academia, is that they'll usually go through like a new library or a new paper, but they'll explain it down into layman's terms so as to get like the developers caught up on all the latest and greatest techniques. And, now that document summarization, for example, is now becoming a neat thing in NLP, and we were talking about like how we're trying to find all the latest areas of research and apply it, it's now easy for maybe someone to come up with a novel document summarization theme. So instead of someone having to like painfully look through papers, people can look at like all the document summaries and see what's going to be more fruitful for further research. And Kaggle obviously has a lot of up and coming data scientists, whether it's developers getting interested or people who are making the transition. So I think it's a great community to go and socialize with fellow data scientists and see what is all the latest and greatest.
perfect. Love it. Absolutely. I didn't know they had a YouTube channel. Going to subscribe immediately.
Yeah.
Yeah, me too.
Yeah. Awesome. Laurence, do you have any picks?
I do. So down the years, I've written many, many computer books, but then I thought I had retired from writing computer books. And then I discovered this one from Aurélien Guérin, the hands-on machine. Yeah, there you go. And this one inspired me in two ways to get back in. First of all, it's a brilliant book. I thoroughly recommend it, but it's also a pick for me because it inspired me in two ways to get back into writing books. One of them was I realized that, this is amazing, but it needed a complementary book for beginners to help them understand this a little bit better. So I've written that book. So that's coming out next month from O'Reilly. And it also has like a little lizard on the cover. So I think they're going to look great together. Mine has a fan-tailed gecko. I'm not sure what this one is. So it's, I'm looking forward to putting the two of them side by side. So that like really deeply inspired me when I read this book. I go, oh my gosh, all the things I don't know are in here, and which is fabulous. And like I said, it also got me to write another one. And then do we have time for a funny story about this book?
Yes, absolutely.
Okay. So I happened to spend a lot of time, or pre-COVID, I happened to spend a lot of time in Japan. And Japan is one of those countries that still has amazing bookstores. They haven't been kind of damaged by the move away from retail towards the web. And there's a bookstore in Japan that I read about that is close to the Imperial Palace Gardens. And they keep bees on the roof of this bookstore. And these bees pollinate the gardens of the Imperial Palace. These bees generate a lot of honey, and there's a cafe in the bookstore where you could go and like you can buy products with that honey. You can have coffee with that honey in it and that kind of stuff. So I thought, I got to check this place out.
Yeah.
And I finished work and I got on the subway and went over there and I found the bookstore. I walked in the front door of the bookstore. The first book I saw was this. Right? And this is a general bookstore, not a computer bookstore, but like Aurelian's book was like everywhere. I was like, wow, that kind of stuff. And then I thought, okay, I want to check. Oh, I was looking to buy a book and I ended up buying it. Hang on one second.
Yeah. If the listeners at home,
have you seen
Laurence
this one?
went down to the study to grab one of the books from the library just now. So
have you seen this book? I was looking to buy this one.
No.
So this is the manga guide to machine learning, where they teach you machine learning using manga. It's brilliant.
Oh my
God. It really is. And there's a guy on the cover, if you know our team, Jason, this guy here, it looks like Wolf Dobson.
Yeah.
He's one of the guys on our team. So I was looking to buy that book, and then Aurelian's book was everywhere in this bookstore. And, I know Aurelian, so I was like kind of texting him and sending him pictures, like, your bloody book is everywhere. I went to the computer department, like on the third floor, and the first thing you get off the escalator was Aurelian's book. And then I went back to try and find the machine learning books to buy this one, and it was buried amongst like 20 copies of Aurelian's book. So after that, I thought, I need to write a book for O'Reilly, and and Aurelian's book is great. And so I pitched them that, and I pitched them, hey, I told them that story. This is why I want to write the book. So I said, like, what brought me there was the honey, and I went to the cafes for the honey. And so I want an O'Reilly book, but I want a bee on the cover. And, apparently they don't do insects on the cover because insects are bugs.
Okay.
I got a lizard instead, but that's okay. So my book is coming out next month. And so my pick is Aurelian's book, and then next month my book.
I love it. You know what I could say is that what you should say is that in the lizard's stomach is a bee. You just can't see it. Just tell people they need a UV light, and then just see how many people will buy your book.
If you're ever in Japan, check out that bookstore, and the honey is delicious. So.
I really, really, really want to go visit Japan. I started loving Japan back when I started programming Ruby. And it was a goal to go to RubyConf, but I don't get to do Ruby anymore. So it doesn't mix very well with any of the technology I use. So.
I hear it's on Rails now.
Yeah, hopefully they'll get that to go over water, and then I'll get my way to Japan. So that's perfect. Awesome. And Laurence, I'm going to totally buy your book as soon as it's available. Let me know. And whenever the world opens back up, I'm going to find you and I'm going to make you sign it. So that's what's going to happen.
That's good.
It's a great time. Thanks everybody for coming in. This was a fantastic podcast. I'm looking forward to when it gets released. And thank you everybody for coming in chatting today. And that's Adventures in Machine Learning.
Thanks for having us.
Thank you.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.